Alright, so let's try another one. So we have the function n of x equals negative x squared minus 4x plus 10. So we know the y-intercept is 10. The vertex for this one isn't clearly known, but we do know the parabola is going to look upside down like this, and the vertex is going to be to the left of the y-axis. So we're going to just go ahead and say let's find the equation of the tangent line when x equals negative 1. So first of all, I need to go ahead and find the y-coordinate associated with that x value. So I'm just going to substitute negative 1 in everywhere I see x. Okay, oops, I should have put negative 1 here. Alright, so as a reminder, order of operations says I have to deal with the exponents first. So this becomes negative 1's quantity squared is positive 1. Okay, negative 4, this is negative 1 times negative 1 is positive 4 plus 10. I'm just going to simplify. Negative 3 plus 4 plus 10 is 14. So n of negative 1 equals 11. So when x equals negative 1, y is 11. Okay? Alright, so let's go ahead and differentiate now, because I need to find the slope at point negative 111. So n prime of x, so I'm just going to do this kind of fast. I get negative 6x, so I just kick negative 2 forward, times it by negative 3, and subtract 1 from my exponent, minus 4. Okay, that's my gradient equation, if you will, or what I got when I differentiated. And now I'm going to go ahead, and since I'm trying to find the gradient when x is negative 1, I'm going to go ahead and plug negative 1 here, and this is going to tell me the gradient of my tangent line. Okay, so when I do that, I get 6 minus 4. So the derivative at negative 1 is 2. Okay, so that means for my tangent line, my slope is 2. Alright, so remember we're going back to this equation, y equals mx plus b. So here we go, let's go ahead and start inputting values. So y is 11, so I'm going to put 11 in for y. My slope is 2, here we are, at 2. My x value is negative 1, and the value I don't know is b, so I'm going to just leave that as b. Alright, so I end up with 11 equals negative 2 plus b. Add 2 to both sides and I get 13 equals b. So now I can go ahead and write this equation. So y equals my slope, which is 2, times x plus 13. Okay. So if this was negative 1 and 11, my tangent would look something like this. Okay. Alright, let's do one more. We'll call this 1 m of x. And we're going to actually put this in vertex form. So we'll say x minus 2 quantity squared plus 3. Okay, so what we know is our vertex is at 2, 3. Okay, there's no stretch or shrink, so it's just the width of a regular parabola. And we can't tell what the y-intercept is from here. We also, at this point, don't know how to differentiate when it's in vertex form, so what we need to do is we need to rewrite this. Because there's a special rule called the chain rule to help us deal with things in parentheses, and you haven't learned that yet. So I'm just going to expand this out. Okay, and rewrite m of x so that every term, there's no multiplication, there's nothing squared. Okay, so minus 4x plus 7. Alright, so let's go ahead and, let's do something very exciting. Let's find the equation of the line when x equals 5. Okay? So when x equals 5, so that would be over here somewhere. So the first thing we're going to do is we're going to plug 5 into m of x equation to find the y-coordinate. So remember I said earlier in the year that math has a lot of substitution going on, and you can see from these problems that that definitely is the case. So 5 squared is 25 minus 20 plus 7. That means y is 12. So we could say that this point is 512 if we wanted to. We could write it over here. Okay, so now it's time to find the derivative of m of x. And remember, we're using this equation because we don't know how to do this yet. So the derivative of x squared is 2x. The derivative of negative 4x is negative 4, and the derivative of 7 is 0. So we're done. Now we need to find the gradient, and the way we do that is we plug this into the gradient equation. Okay, so we're going to say the derivative of m when x is 5 equals 2 times 5 minus 4. So that means we end up with a value of 6. So our slope, also known as our derivative in this case, is 6. So now we're just going to go ahead and plug values into our equation. Okay, so everywhere I see y, I put in 12 equals. Everywhere I see my slope, m, I put in 6. Everywhere I see x, I put in 5. And the value I don't know is b, so that's what we're going to solve for. So I end up with 12 equals 30 plus b. Subtract 30 from both sides, and I end up with negative 18 equals b. So to rewrite my final equation, I say y equals my slope, which we found from the derivative, which is 6x, minus 18. So if I were to sketch this tangent line, it would look really, okay, well, that's not exactly how it would look. It would look, I'm really bad at drawing on this tablet. Okay, we'll pretend this is a straight line. It would look something like this. Okay, and this point would be negative 18. Okay. Alright, so that is how you find the equation of tangent lines.